All right, so college algebra notes for section 2.3. Our topics, we're going to calculate slope, a line's slope. We're going to look at several different equations. We've got point-slope form, we have slope-intercept form, and general form or standard form. We're going to look at all three of those and how we go back and forth between them and what are the pros and cons of each one. We are also going to look at graphing horizontal and vertical lines as well as graphing using intercepts. Okay? All right, so at your tables, talk about what kinds of information do you need to know if you're going to write an equation for a line. All right, what did you come up with? Slope, okay. What else? Y-intercept. Anything else? I would agree. If you know a slope and a y-intercept, what's your equation? What do you plug it into? Y equals mx plus b, right? That's a quick one. What if you're not given slope? What might you be given? You might be given some coordinate points, all right? If you have 2 points, can you come up with a line? Yes. Okay, so you don't have to be given slope. You maybe are given things to help you find slope. Okay. All right, so slope is used in a lot of different things. When we talk about lines, they have a constant rate of change or a constant slope. You're going to talk about rate of change in future math classes looking at, say, a parabola. All right, and the rate of change isn't constant. It depends on where you are on that parabola, how steep it would be. Okay, the farther up you go, the steeper it gets. All right, so that's a case where rate of change is not constant. But if we are talking about strictly linear equations, which is what our topic today is, we have a constant rate of change or a constant slope. It doesn't matter what 2 points on that line you use, you're always going to get the same slope. All right, so for linear functions, slope would be change in y over change in x. That's one way we could talk about slope. Change in y over change in x. What's the equation we have for that? Okay. y2 minus y1 over x2 minus x1. If we were looking at a graph, what do we often think of? Rise and run. Yep. Have you seen this symbol before? Have you seen that? Delta y over delta x. It's just another way of saying change in y over change in x. Shorter way of writing it. Okay. And there was a little hidden tidbit. Interesting fact. Do you know why we use the letter M for slope? Comes from the French word monter. That means to rise or ascend. See? Was worth coming to class today just for that, right? Now you know why we use an M. Okay. And I might not be pronouncing it correctly. I don't speak French, but. All right, find the slope of the line passing through these given points. Which ones go on top? The y's. Which one are the y's? Second coordinate in each. Does it matter if I do -1 minus 4 or if I do 4 minus -1? No. However, whatever you decide to do for order, you have to do the x's in the same order. Yes? Remember that? Okay, so if I do -1 minus 4, I have to do -3 minus -2. All right. On the top, I get -5. On the bottom, I get -1, which gives me a slope of just 5. Yes? Okay. Go ahead and do part B. Okay, you should have ended up with a slope of negative 7/5. Yes? Now notice that I used both different ways of doing this, okay? On here, I took the first point minus the second point. Down here, I took the second point minus the first point. The only change is which one ended up being negative. But there still is a negative sign there, so it's still considered a negative 7/5 slope, okay? Some people just put the negative straight out front in the middle. They don't tack it on the top or bottom, okay? All of those are equivalent. All right, so pictures quick of our 4 different types. If we have a positive sloping line, what does it look like? All right, so it should rise as you go from left to right. Negative sloping line then would fall. Going from left to right. The ones students often get mixed up. Which one has a 0 slope? Horizontal or vertical? Which one has 0 slope? Horizontal. Horizontal has 0 slope. Vertical has no slope. Now, why is that? What is my rise in a horizontal line? 0. 0 over any kind of run, right? I can do that. I can take 0 divided by a number. I just get 0. That's why my slope is 0. Over here, I rise, but I have no run. That's what I can't do. I can't divide by 0. So that's why we can't calculate a slope for vertical lines. All right. So we're going to, like I said, look at 3 different types of equations for lines. The first one is point-slope form. How many think they remember point-slope form? Vaguely, in the back of my mind somewhere. It's sort of foggy. Yes? Do you remember hearing the term point-slope? Okay, great. Does this look familiar? All right. Y minus y1 equals m times x minus x1. Jot it down. Now, notice that if we took this piece right here and we divided it to the other side, it'd be our slope formula, right? Change in y over change in x. So it's just another way of looking at that formula for slope. Notice that the red pieces, that x1, y1, those are specific. It's a specific point that your line is going through, okay? You're going to substitute numbers in there. You're going to put a number in for slope, for m. The black x and y in that equation stay as x and y. Okay, those are your generic. They stand for all points on your line. Okay, so our first one says find an equation for the line that has a slope of 6 and passes through the point 2, negative 5. All right, so plugging it in, y minus what? Negative 5 equals my slope times x minus my x coordinate. Okay, now we could simplify a little bit here, like the subtracting a negative, I probably would just put as y plus 5. We're going to stop there for a minute. We'll come back to this question. But right now, I have an equation in point-slope form. If the test asks you to write an equation in point-slope form, you're done. You stop there. Okay? Go ahead on your own and try the next question. You're given 2 points, so what's your first task? Find the slope. All right, let's check. M equals change in y over change in x. Did you get a slope of negative 5? Okay. Does it matter which point you use? No. So if I use the first point, I would have the equation y minus -1 equals -5 times x minus -2. Simplifying my two negatives gives me that. Yes? Okay. If I use the other point, simplifying, I've got y plus 6 equals -5 times x plus 1. Looks like two different lines, okay? But it should be the same line, yes? In point-slope form, depending on which point you use, you're going to get a different looking equation, all right? But again, if it says write it in point-slope form, we would stop there. In order to get these two equations to look the same, we would have to simplify it down into slope-intercept form. What does that look like? Slope-intercept form. Yes, y equals mx plus b. So we're going to go back and we're going to simplify the previous two examples into slope-intercept form. So our first one was y plus 5 equals 6 times x minus 2. How would we simplify that? Distribute first. And then yes? Okay. So how many of you had the one I have in green here for example 3? How many of you wrote this version? Okay, did anybody write the blue version? Okay, take whichever one you wrote and simplify it down into slope-intercept form. We should all get the same answer out. All right, do they match? So again, it doesn't matter which form or which point you use in point-slope form. When you simplify it down to slope-intercept form, it should all match. Okay. All right, so horizontal and vertical lines. How do we write an equation for a horizontal line? Give me an example of one. Okay, it has to be an equation, so y equals 2 would be an example of one. All right. Typically we say just y equals b, where b is some kind of constant. Could we also write it like this? F of x equals b. Is a horizontal line a function? Does it pass the vertical line test? Yes. So I could put it in function notation like this. F of x we typically use to replace y when we want it in function form. Okay. What kind of equation do we write for vertical lines? Picture a vertical line. Yes. X equals something. So x equals some constant. But a vertical line is not a function, right? Doesn't pass the vertical line test. So we can't write it in f of x notation. There is no y in the equation to replace with f of x. All right. We're going to graph each of the following. What shape would this be? Y equals 4. That is a horizontal line at 4. Okay, that's graph A. How about graph B? X equals -6. That's a vertical line. What about C? Could we simplify and solve for that X? All right, let's subtract our 12 over, so 3x would equal -12, and then x would be -4, which turns it into what kind of line? Vertical again? All right, x is -4. All right, f of x equals -2. Horizontal? All right, at -2. We okay with those? All right, what is another name for y equals 0? Picture where it would be on your graph. Y equals 0. It is the x-axis, yep. And x equals 0 would be the y-axis. All right, so the last topic that we're going to look at today, we just have one more side left, is general form. Now, different books show general or standard form in different ways. Some books have everything on one side. It's equal to a 0. So you've got your AX, your BY, and your constant C all on one side. Other books, I think your Algebra 2 book last year had C on the other side. Okay? I'm okay with either version. The one thing I do want you to make sure you do is that your A, B's, and C's should be integers. Okay? I don't want to see fractions. I don't want to see decimals. And we'll go over how to get rid of those and convert them in a second. Notice it says that A, B, and C are real numbers, and A and B cannot both be 0. Okay? If A and B are both 0, they drop out. You can have one of them 0. Okay? If you just have an X, it's a vertical line. If you just have a Y, it's a horizontal line. Okay? But you can't have both of them be 0. Equations can be converted from one form to another. We just showed that you could take point-slope form and convert it into slope-intercept. You could take slope-intercept and convert it into general form. You can go back and forth between them, with one exception. What's the one kind of line that we can't put in other forms? It has to be in general form. We just graphed them. Vertical. Because the other forms have a y equals mx type of equation, right? Meaning it has to have a slope and it has to have a y. A vertical line doesn't have a slope and it doesn't have a y. So it can't be written in that form. So vertical lines are always considered in general form. And each form has strengths and weaknesses. One of the nice things about general form is it's pretty easy to find the x and y intercepts, and we can use those to graph. All right, so if you are finding x and y intercepts, it's probably going to be easier to move the c term to the other side. So let's think of this as 4x minus 3y equals 12. If we put a 0 in for y, what we are finding is our x-intercept. If we put a 0 in for x, we are finding our y-intercept. Okay? So you're just going to go through one at a time and replace one of your variables with 0. If we put a 0 in for y, the 3y piece is gone. And we are just solving for x equals 12, which means x would have to be 3. Okay? If we put a 0 in for y, sorry, for x, then the 4x piece is gone, and we have negative 3y equals 12. So y would be negative 4. Okay? Graphing those points. 0, negative 4 is our y-intercept, and 3, 0 is our x-intercept. And then it's just a matter of drawing a line through. Typically, if I'm asking you to plot points and draw a line, I would want 3 points. This would be the one exception. If you have the 2 intercepts, I'm okay with that being the only 2 points you use. All right, so at your tables, go ahead and try B. All right, checking. Let's move the 9 to the other side. If we replace y with 0, the 2y is gone. X would have to be negative 3. If we replace x with 0, then y has to be, yes, negative 4.5. All right, so negative 3 for an x-intercept and negative 4.5 for a y-intercept. You okay with that form? All right, the last piece, I added 2 examples in here. I said that you had to get integer coefficients. So let's say you have the red equation here, has some fractions in it. What was the technique we have for getting rid of fractions? Multiply by, if we have several different fractions in one equation, multiply by common denominator, right? Figure out what that LCD would be. So if I have a 2 and a 3, my LCD is 6. If I multiply everything by a 6, I know that all those denominators are going to cancel out. Okay? What's 6 times 1/2? So this becomes 3x. 2/3 times 6. 6 times 2 is 12 divided by 3. Okay? Another way of thinking about that, 3 goes into 6 twice. 2 times 2 is 4. Don't forget to multiply the 6 to the other side as well to get 30. Okay? And now you have an equation that's much cleaner looking. No fractions in it. Okay? What if you have decimals? How do we get rid of decimals? Think about what this would be as a fraction. This is 2/10. This is 5/100, right? What would your LCD be? 100. If you times by 100, how many spaces does your decimal move? 2. If I move my decimal 2 places, this one 2 places, this one 2 places, will I get rid of all my decimals? Yeah. So what I'm really doing is multiplying by a number that's going to move those decimals out of the way. Okay? And this one had the most decimal places of 2. That means I need to multiply by something that has 2 zeros, or 100. All right. Moving my decimal 2 places moves it past the 2 and then 1 more, so that becomes 20x. This becomes 5y, and this becomes 200. Okay? So anytime you have fractions and decimals in an equation, you can get rid of them. All right. So you guys are going to do 1 through 31 odd and then 49 to 73 odd.